Imagine spending, I don't know, 3 agonizing months building a lightning-fast, highly optimized NextJS web application.
Right.
You've tuned the CSS, you've obsessed over the React components, and everything looks totally flawless on your local machine.
Of course.
But then launch day arrives, real user traffic hits, and suddenly you realize that a single massive monolithic database bottleneck on your backend is adding like 3 full seconds of load time to every single page view.
Oh yeah, the absolute worst.
Your bounce rate skyrockets, your SEO ranking just completely tanks, and all that front-end optimization is completely wasted because your content delivery architecture fundamentally cannot scale.
It is the classic developer nightmare, honestly. You build a Ferrari, but you force it to drive on a dirt road.
Right.
The infrastructure just completely throttles the application.
Okay, let's unpack this, because avoiding that exact nightmare is exactly what we were focusing on today. Welcome to your deep dive into the Contentstack Developer Onboarding course. We are looking at a curriculum specifically designed to transform how you architect, build, and scale web applications.
Exactly.
If you've been stuck in the world of traditional monolithic content management systems, where the database, the back-end logic, and the front-end rendering are all just hopelessly tangled together.
Yeah, total mess.
Right. Today is about breaking out of that box. We are going to explore the transition to a modern, decoupled, headless CMS. You're basically getting the ultimate developer cheat sheet for this whole ecosystem.
And it's really important to emphasize right from the start that this onboarding course isn't just some theoretical white paper.
Right.
It is an aggressively practical blueprint. To truly master a system like Contentstack, you have to move past merely copying and pasting code snippets from documentation.
Oh, for sure.
You need a comprehensive understanding of why the architecture is designed the way it is.
Yeah.
Like if you just memorize syntax, the minute you encounter a novel architectural challenge in production, you'll be totally paralyzed.
Yeah.
But if you deeply understand the mechanics of how content creation is isolated from content delivery, well, you gain the technological freedom to build virtually anything.
I think that's where a lot of developer onboarding falls short, honestly. They teach you the what without the why.
Exactly.
So before we even touch a terminal window, let's talk about the destination. The course operates on a project-based learning model, right? The main objective, the finish line, is building out 2 specific views.
Mm-hmm.
A hero detail page and a hero gallery landing page.
Right.
Now, to a designer, a hero page is just like a big banner image with some text. But technically, architecturally, what does building these pages actually require from a developer?
So under the hood, it represents a complete full-stack data lifecycle.
Okay.
You aren't just painting a web page. First, you have to architect the data schema in the back end. In Contentstack, this means creating new content types. You are explicitly defining the shape of the data, specifying that a hero object must contain a string for the title, a reference URL for an image asset, and perhaps a nested object for a call to action button.
Got it.
You are basically building the database schema without ever having to write SQL tables.
Right, so you're modeling the content.
Precisely, yeah. Then you pivot to the front end. You have to build the Next.js components, the actual React code that will consume that specific data shape.
Okay.
And the bridge between those 2 environments is the 3rd step. You have to engineer complex content delivery API queries to fetch precisely the data you modeled and inject it seamlessly into the components you just built.
And the course materials indicate that this isn't just like a basic Hello World text fetch.
No, not at all.
The curriculum pushes into advanced territory. Like you're working with localization, right? Managing how that hero page renders if a user in Paris requests it versus a user in Tokyo. You are dealing with image optimization, which directly impacts those web performance vitals we mentioned earlier.
Exactly.
It even covers integrating the automation hub and pulling in third-party marketplace apps.
Which really highlights a broader industry shift toward composable architecture.
Yeah.
You are no longer buying a single software suite that tries to do everything poorly. You are assembling a highly specialized stack using best-of-breed tools.
Right.
And Contentstack essentially acts as the central nervous system for all that content.
Okay, so we know what we are building. The hero pages are the mountain peak. But let's look at the actual starting blocks. The course is very prescriptive about how you set up your local workspace.
It is, yeah.
Step 1, you have to create a dedicated training instance by going to the Legacy Contentstack Academy site.
Right, and that provides a totally quarantined environment. It's just a fundamental best practice Never learn a new tool by plugging it into your production database.
Oh yeah, please don't do that. Step 2 is where things get really interesting, though. You don't start by running create next app and staring at an empty directory. The course actually has you pull down a specific pre-built code base from an official GitHub repository.
Right. The Contentstack Academy Playground.
Yeah, so you clone this down to your machine. Step 3 is the crucial configuration step. You take a file named .nv.local.sample, rename it to .nv.local, and map your specific environment variables. Then, step 4, you run your standard npm install for the node modules and npm run dev to launch the local server.
And suddenly you have a fully functional NextJS application running on localhost, ready to ingest data.
Okay, wait, I have to push back here.
Sure.
As a developer, my instinct when learning a new technology is to build from scratch. If the goal is to learn how Contentstack integrates with NextJS, doesn't handing me a pre-configured GitHub repository completely defeat the purpose?
I can see why you'd think that.
Yeah. Like, if I don't set up the routing, if I don't configure the API helper functions myself, aren't I just becoming a black box developer who doesn't actually understand the plumbing of the house I'm standing in?
That is a highly valid concern. And honestly, it's a debate we see constantly in developer education.
Yeah.
But we have to look at the historical context of front-end development over the last, say, 5 to 7 years. We went through a period of extreme boilerplate fatigue.
Oh, the dark days of manual Webpack configurations.
Exactly. If a course asks you to start from an empty folder, you will likely spend your first 4 hours arguing with Babel plugins, CSS and JS configurations, ESLint rules,
Oh, it's the works.
and all those Next.js routing paradigms.
Right.
By the time you finally get your environment stable enough to make a single HTTP request to Contentstack, you are just cognitively exhausted.
That is very true.
The goal of this specific onboarding is not to teach you the fundamentals of React or how to configure a build tool. The goal is to teach you headless architecture.
I hear that, but aren't we just trading one abstraction for another?
We are, but it's a very strategic abstraction. By using a production-ready starter app, Contentstack eliminates the friction of the setup phase.
Okay.
It allows you to focus 100% of your cognitive load straight on the data integration, the content modeling, and the API interaction.
So you get straight to the point.
Exactly. You get to examine a best practice implementation from minute 1. You can look at the code base and see exactly how senior engineers at Contentstack recommend structuring a Next.js project to consume their APIs.
That makes sense.
It's a difference between learning how to design an engine versus spending 3 days learning how to mine the iron ore to build the engine block.
Okay, that distinction makes total sense. You need to focus on the API integration, not fighting with dependency conflicts in your package.json.
Right.
So we have our local Next.js sandbox spinning, just waiting for data. But to understand how that data arrives, we have to look at the actual machinery supplying it. Let's look at the blueprint of a headless CMS. The term headless gets thrown around constantly in tech blogs, but what are we actually severing here?
We are severing the relationship between content creation and content presentation.
Okay.
In a legacy monolithic system, the database where you write your blog post and the HTML templates that render that blog post for the user,
Right.
they are tightly coupled.
Right.
They run on the same server,
Right.
often relying on the same back-end language. Headless completely severs that link. The CMS becomes purely a content repository,
Sure.
a head without a body.
I like to visualize this decoupling using a restaurant analogy.
I like that.
Think of the back end of Contentstack, the headless CMS, as the kitchen of a high-end restaurant. The diners sitting out in the dining room, those are your website visitors.
Right.
They never see the kitchen. They have absolutely no idea how the walk-in freezer is organized or what kind of stoves the chefs are using.
Exactly.
But for the chefs, the content editors and marketing teams, that kitchen has to be incredibly intuitive, organized, and flexible.
It's a really fitting analogy. The back end of Contentstack is heavily optimized for the human experience.
Right.
It focuses on ease of use, providing a highly flexible user interface for content creators to draft, review, and organize data without needing to know a single line of code.
And crucially, the course points out that this back-end kitchen is extensible. You aren't locked into the default appliances, right?
Exactly. Developers can use the app SDK to build UI extensions.
So, let's say your marketing team needs to embed products from Shopify directly into a blog post.
Yeah.
Or they need to pull high-resolution assets from a corporate digital asset management system.
Yeah, a developer can build a custom extension that surfaces those third-party tools directly inside the Contentstack editor. The chefs get exactly the custom tools they need right at their prep station.
That is super powerful. But eventually, the meal has to leave the kitchen. The data has to reach the diners. And this is where the architectural split becomes critical.
It is.
Because the front end, the dining room, the delivery engine, operates on an entirely different set of priorities.
Right. While the back end optimizes for human flexibility, the front end optimizes purely for machine performance.
Exactly.
The front end application, in our case the NextJS app, executes read-only queries. It doesn't care how the content was drafted or who approved it. It just asks the API, give me the published data for the hero component, and it expects an answer in milliseconds.
And achieving that millisecond response time globally is where headless architecture introduces a massive infrastructural advantage.
Oh, huge. What's fascinating here is how they solve the physical distance problem.
Right.
In a traditional monolith, if a user in London requests a web page, that request might have to travel all the way to a primary database server in New York.
Yeah, and that takes time.
The server has to query the database, stitch the HTML together, and send it back across the Atlantic. That network latency is just a physical limitation.
And this is where the Content Delivery Network, the CDN, changes the game entirely. I want to spend some time here because the course really emphasizes this, and it's fundamental to the performance gains of Headless.
Absolutely. To ensure lightning-fast global performance, Contentstack relies on an internal CDN to cache all these queries.
So let's walk through the mechanics of that.
Okay.
A user in Tokyo opens your NextJS application on their phone. The application fires off an API request for the homepage data. Because of the CDN, that request does not travel to New York.
Correct. The routing protocol detects the user's location and directs the API request to the nearest edge node, perhaps a server physically located right there in Tokyo.
Oh.
That local server already holds a cached copy of the JSON data, so it returns the payload almost instantaneously.
That's incredible.
This edge caching dramatically lowers time to first byte, which is a critical metric for both user experience and search engine optimization.
And because it's just sending lightweight JSON data, not fully rendered HTML pages with heavy server logic, the payload itself is incredibly small.
Right.
So why should you, the listener, care about this? What does this decoupled CDN-backed architecture actually mean for your development team?
Well, it grants total technological freedom.
Exactly. If your team builds the front end in Next.js today, but say 3 years from now, a revolutionary new front-end framework emerges that is twice as fast, you can completely rip out your Next.js front end and rebuild it.
And your back-end content doesn't change at all, not a single comma.
You don't have to migrate databases. You just point the new front end at the existing Contentstack APIs. It totally future-proofs your content infrastructure.
It really does. However, this is a big however, this physical and logical separation introduces a highly complex security challenge.
Oh, right.
If your front-end delivery engine is sitting on a server in Tokyo and your back-end management system is centralized elsewhere, how do they establish trust?
Right. How does the edge node know that the specific application asking for the data is actually authorized to receive it?
Exactly. And more critically, how do you prevent the nightmare scenario?
Oh, you mean where your marketing team is drafting a massive, highly confidential rebrand in the back end, and somehow your live production website accidentally queries and displays that unfinished draft data to the public?
Yes, which happens more often than companies care to admit in poorly configured systems.
That is terrifying. So how do we secure the perimeter?
Right.
This brings us to a critical module in the onboarding course environments and tokens. This is the vault keys, the routing and authentication infrastructure that keeps the data strictly siloed. Let's define the boundaries first. The course introduces the concept of environments, which are basically just distinct published destinations.
Think of environments as parallel dimensions of your application.
Okay.
The industry standard usually involves at least 3. You have a development environment where engineers test new code and experimental data structures.
Right.
You have a staging or preview environment where content editors can see exactly how their draft content will look before it goes live. And finally, you have the production environment, which is the live, public-facing application.
And the power of Contentstack is that one single stack, one unified backend repository can manage the content for all of these environments simultaneously. An editor can publish a press release to the staging environment for legal review, and it remains completely invisible to the production environment.
Exactly.
But how is that invisibility actually enforced at the code level?
It is enforced through a strict 2-key authentication system.
Okay.
Whenever your front-end application attempts to fetch data via the API, It cannot just ask nicely. It must present two cryptographic proofs of identity in the HTTP request headers.
The first is the API key.
Yes. The API key is unique to each stack. There is only one per stack.
Right.
If your organization is building the global e-commerce hub, that entire overarching project is a stack, and it is assigned one unique API key. Presenting this key tells Contentstack servers, hey, I belong to the global e-commerce hub project.
But the API key alone isn't enough to get the data.
Oh.
The documentation makes it abundantly clear that most API calls require a second key to work the delivery token, which is sometimes called an access token.
Right.
And this is where the siloing happens. The delivery token is unique not to the stack, but to the specific environment.
Exactly. Development gets its own unique token. Staging gets a different one.
Right.
Production gets a completely different one.
No, wait, this seems a bit redundant.
How so?
If I already have a unique API key for my entire stack, why do I need a separate delivery token just to pull content? Why two keys?
It's a fail-safe routing and security mechanism. Let's go back to your building analogy from earlier.
Oh, the corporate security one.
Yeah. The API key identifies the entire building. That's the stack.
Right.
But the delivery token acts as the specific ream key, the environment.
Okay, building badge and room key, I like that.
Your employee badge gets you through the front door, but it does not grant you access to the server room or the HR files. For those, you need specific compartmentalized clearance.
Right, that makes sense.
So why is this vital? Let's say a junior developer is working locally on their laptop, building out a new feature.
Okay.
In their local.n file, they configure the API key for the stack, and they configure the delivery token specifically for the development environment. Because the API routing strictly requires both, the Contentstack servers will only ever return data that has been explicitly published to development.
So even if they write a completely broken wildcard query that says just fetch everything, they physically cannot pull data from production.
It is cryptographically impossible.
Yeah.
The edge nodes will validate the token and absolutely refuse to serve production data.
Wow.
This compartmentalization is a massive fail-safe. It ensures that a developer working on a local testing environment absolutely cannot accidentally query or alter the live production data.
And it means that if an intern accidentally leaks the development delivery token on a public GitHub repository, the blast radius is contained.
Exactly. A malicious actor might be able to read your test data, but your live production site and your highly confidential unreleased content remain securely locked behind entirely different tokens.
That distinction is so crucial. It's not redundancy, it is risk mitigation built right into the infrastructure. All right, so the developer has their workspace configured. They understand the mechanics of the CDN cache. They have their API key and their specific environment delivery tokens securely loaded.
Yep.
They are ready to actually ask for the data. What is the actual vehicle they use to extract the data?
Enter the Content Delivery API, or the CDA.
The CDA. The course positions this as the developer's main tool for retrieving content to display to users.
It is.
And we should clarify the landscape here because Contentstack does offer several APIs.
Right, you have the Content Management API, which is for writing and updating data.
Like if you were writing a script to automatically import thousands of articles from a legacy database.
Exactly. And then there's the Images API, which is used for on-the-fly image transformations, like dynamic cropping or resizing.
But the CDA is strictly for content retrieval. It is the read-only pipe that connects the cached CDN to your application.
Yeah.
And the onboarding course emphasizes a few core architectural strengths of the CDA that fundamentally explain why Headless has taken over. The first strength is its profound agnosticism.
Right. The CDA doesn't care if you're building in React View or a traditional HTML setup. It just serves pure data.
Which means if you're building an internal dashboard in Angular, a public website in NextJS, and a native iOS app in Swift, they can all query the exact same CDA endpoint and receive the exact same data.
It creates a true single source of truth.
Okay, here's where it gets really interesting.
Yeah.
The second core strength is efficiency.
Oh, yeah.
In a legacy system, if you clicked a link to view a blog post, the server had to process the entire HTML page. It sent the header, the navigation menu, the sidebar, all at once.
A massive payload of redundant data.
Right, but the CDA allows developers to fetch only the specific content they need. Give me an example of how that looks in practice for our hero page.
Let's say your NextJS component for the hero page is incredibly lightweight. All it needs is a background image and a headline. When you construct your CDA query, you don't just ask for the whole hero content type. You can append parameters that explicitly say, hey, only return the hero title string and the hero image URL. Exclude the author data, exclude the SEO metadata, exclude everything else.
So you are trimming the fat off the response before it even leaves the server.
Exactly. This radically reduces data transfer sizes and totally boosts site speed compared to traditional CMS page loads.
And the third major feature the course highlights is native multilingual support,
which is critical for global enterprise applications. Managing localization in traditional systems often meant maintaining entirely separate website trees. It was a nightmare.
But with the CDA, it natively supports fetching content in multiple languages. If your backend editors have translated a piece of content, the front-end developer simply appends a locale query parameter to the request.
Right. Send locale equals Ennis, you get English. Send locale equals Rayo, you get French.
Connecting this back to the big picture for you listening, this API is what makes true omnichannel delivery possible. Because the API serves pure, unstyled data, that content is entirely liberated from the concept of a web page. The exact same JSON payload can feed a website, a mobile app, or a digital billboard.
It's created once, managed centrally, and delivered anywhere.
So cool. Okay, we have talked about the CDA in theory. We've got our keys. We understand the decoupling. But eventually, theory has to meet practice.
It does.
How does a developer actually test this and see the raw data before hard-coding anything into their NextJS app?
This is a crucial workflow habit. You have two entirely separate systems, your front-end code and your back-end API. If you try to write a complex fetch function in NextJS and the data doesn't render, you are faced with a frustrating debugging scenario.
Right. Is my React code broken, or did the API just return a 404 error?
You never want to debug both sides at the same time. You must independently verify that the API is returning exactly the JSON structure you expect.
And the course provides two very distinct methods for achieving this. Method 1 is designed for absolute immediate feedback. You don't even have to leave your web browser.
The try feature?
Yes. Walk us through querying directly from the browser using the try feature in the documentation.
It's super simple. You navigate to the Get All Entries section in the CDA docs. Right there on the page, there's an interactive console.
Okay.
You plug in your AP key, your access token, your environment parameter, let's say preview, and your locale.
And you specifically need the content typoid, right? The course uses a blog post as the example.
Yep. You plug that in, and you hit the try button, and instantly you see the live JSON response rendered right there on the screen.
That is so convenient. You can physically verify, yes, my keys are valid, and yes, the data exists.
It provides instant validation. But as your application grows, the documentation console isn't a sustainable environment for professional development.
Right, which brings us to method 2. Leveraging Postman, which is basically the industry standard software for API testing.
Exactly. It allows you to step up to a much more robust testing environment.
And Contentstack makes this really easy by providing an official Contentstack Postman content delivery collection and that you can just download.
Right. It's a pre-programmed library of all the CDA requests you'd need.
But importing the collection is only step 1.
Yes, and here is a vital expert insight into how professional developers actually use Postman.
Okay.
If you have 50 different saved API requests in that collection, you do not want to be manually copying and pasting your API key and delivery token into the header of every single one.
Oh, man, that would be a nightmare.
Total nightmare. To solve this, Postman utilizes environment variables. You go into Postman settings and you define global variables, AP key, access token, environment, and locale.
You populate those with the credentials from your specific stack?
Exactly. And because the official collection is intelligently pre-written, the requests have placeholder syntax that looks for those exact variable names.
So when you hit send, Postman dynamically injects your variables at runtime. And if you want to switch from testing development data to staging data,
you just update the access token and environment variables in one single place in Postman settings.
So what does this all mean?
It means you map the territory before you build the house.
Right. It synthesizes everything. These tools save developers hours of debugging. By isolating the API query in Postman, you confirm the data exists and is formatted correctly before you ever worry about how to render it in NextJS.
It completely de-risks the integration phase.
Amazing. We have covered a tremendous amount of ground today. Let's briefly recap this journey.
Yeah, we've gone from setting up the training instance and pulling the NextJS repo.
To understanding the whole decoupled architecture and that two-key token system.
Right, and finally pinging the content delivery API to get raw JSON data.
It is a phenomenal roadmap, but before we wrap up, I want to leave you, the listener, with a forward-looking concept to mull over.
Okay.
We've spent this entire time talking about how the content delivery API serves pure, framework-agnostic data, completely stripped of any design or presentation.
Just raw data waiting for an interface.
Exactly. So consider the rapid evolution of artificial intelligence we are currently witnessing. If a headless API is serving pure, perfectly structured data that any machine can easily parse,
Oh, I see where you're going with this.
how close are we to a future where AI can instantly read that data and automatically generate brand new front-end interfaces on the fly, entirely bypassing human UI development?
Wow. I mean, when you fundamentally decouple the content from the presentation layer, it's totally possible.
Right. And AI could just monitor the payload, recognize a hero title, and instantly build a beautifully designed React component for it.
It is an architectural model inherently prepared for generative interfaces.
Something to think about as you set up your workspace. Which part of the architecture, the back-end management, or the front-end delivery are you most excited to dive into first?